In the vast, uncharted reaches of our universe, few celestial objects capture the imagination quite like Betelgeuse. Situated in the constellation of Orion, this immense red supergiant has fascinated astronomers and stargazers alike for centuries. Betelgeuse isn't just any star, it's a stellar behemoth that commands attention, not only because of its enormous size, estimated to be around 764 times the diameter of our Sun, but also due to the intrigue surrounding its eventual fate. What you're about to discover is the story of a cosmic time bomb. Betelgeuse's inevitable explosion could happen tomorrow, or 1,000 years from now, and when it does, it will forever change our understanding of stellar evolution and provide the greatest astronomical light show our generation may ever witness. Betelgeuse, also known as Alpha Orionis, is one of the most recognizable stars in our night sky. Located approximately 550 light-years from Earth, it forms the right shoulder of the Hunter in the constellation Orion. Its distinctive reddish-orange glow has guided navigators and inspired mythology across countless civilizations. But what makes Betelgeuse truly extraordinary is its sheer scale. If placed at the center of our solar system, Betelgeuse's outer layers would extend beyond the orbit of Jupiter, engulfing Mercury, Venus, Earth, and Mars in its fiery embrace. This colossal star has a mass approximately 16 to 19 times that of our Sun, making it one of the most massive stars visible to the naked eye. Despite its immense size, Betelgeuse is surprisingly young. While our Sun has existed for about 4.6 billion years and is only middle-aged, Betelgeuse is a mere 8 to 8.5 million years old, practically an infant in cosmic terms. Yet, despite its youth, Betelgeuse is already nearing the end of its life. This accelerated aging process is common for massive stars, which burn through their nuclear fuel at an exponentially faster rate than smaller stars like our Sun. The surface of Betelgeuse is a turbulent, ever-changing landscape. Massive convection cells, each larger than our entire Sun, rise and fall across its surface, creating a mottled appearance when viewed through powerful telescopes. These convection cells contribute to Betelgeuse's variable brightness, causing it to pulsate irregularly over periods of months to years. Over the years, Betelgeuse has been a source of wonder and mystery, particularly due to its unpredictable changes in brightness. The star's pulsations are not only a testament to its size but also a clue to the tumultuous processes happening deep within it. The most notable event occurred in late 2019 when Betelgeuse's brightness dropped dramatically, an event that sparked a wave of speculation across the scientific community and the public alike. Dubbed the Great Dimming, this phenomenon led many to wonder, was Betelgeuse on the verge of a supernova? Could this be the beginning of the end for one of the most famous stars in our night sky? At its dimmest point in February 2020, Betelgeuse had lost about two-thirds of its normal brightness. This was unprecedented in modern astronomical observations of the star. The dramatic change was so significant that it was noticeable even to casual observers. The usually brilliant orange-red beacon of Orion's shoulder had faded to a shadow of its former self. Scientists quickly turned their attention to this dimming event, using some of the most advanced instruments in existence, including the iconic Hubble Space Telescope and the European Southern Observatory's Very Large Telescope in Chile. Among the team of astronomers involved in the investigation was Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics. They had a singular goal: to determine whether Betelgeuse's dimming was a temporary glitch in its life cycle, or a harbinger of a far more dramatic fate. After extensive observation, they discovered that the dimming was most likely caused by a massive ejection of material from Betelgeuse's surface. This ejection sent a dense cloud of dust into space, momentarily blocking the star's light and obscuring its normally brilliant shine. The discovery came through detailed spectroscopic analysis, which showed that the star's southern hemisphere had experienced dramatic temperature drops, hundreds of degrees cooler than normal. This cooling allowed gas expelled from the star to condense into solid dust, forming a cloud that obscured Betelgeuse's light from our perspective on Earth. However, while this event provided some clarity, it also deepened the mystery surrounding Betelgeuse's future. The ejection of such an enormous amount of stellar material is not a common occurrence in stable stars. It suggested that Betelgeuse might be entering a new phase of instability, perhaps one of the final phases before its ultimate demise. Betelgeuse is now in the final stages of its life, nearing the end of its time as a red supergiant. This phase of a star's life is both its most magnificent and volatile. The star has long ago exhausted the supply of hydrogen in its core and is now fusing heavier elements such as helium, carbon, and even more massive elements like oxygen, neon, and silicon. To understand what's happening within Betelgeuse, we need to delve into the life cycle of massive stars. When a star forms from a collapsing cloud of gas and dust, it initially burns hydrogen through nuclear fusion, converting it into helium and releasing energy in the process. This is the main sequence phase, where our Sun currently resides, about halfway through its 10 billion-year lifespan. But for a massive star like Betelgeuse, this process is accelerated exponentially. Within just a few million years, Betelgeuse exhausted its core hydrogen and began to fuse helium into carbon. This transition marked the end of its main sequence life and the beginning of its evolution into a red supergiant. As this process continues, Betelgeuse is undergoing significant changes. Its core is contracting under the weight of its own gravity, causing it to heat up, while its outer layers are expanding and cooling. This causes Betelgeuse to grow larger and larger over time, eventually reaching a size where it becomes unstable. This instability is what drives the dramatic mass ejections we've observed in recent years. Kindly like, share and subscribe our channel for further more updates about space.